Welcome into another episode of Everything is Logistics, a podcast for the thinkers in freight. I am your host, Blythe Brumleve, and I am happy to welcome in Todd Rigby. He is the Director of Sales at Rajant, and we're going to be talking about communications in the toughest environments and how we make that easier. So, Todd, welcome into the show.
Well, thanks. I appreciate you having me.
Absolutely. So I kind of wanted to start it with a very base level knowledge because on a couple of the Ragent videos that I was watching, it says Ragent Kinetic Mesh extends network range and offers built-in redundancy for ultra reliable wireless underground communications with no fiber required. So from the very basic of level, explain it to me like I'm five. How do you build a wireless network?
So basically, what we do is we use wireless communication nodes, and we call those breadcrumbs. And we basically build a breadcrumb trail. So we put these nodes out. Typically, these nodes have 2 to 4 radios in them. More radios give you more bandwidth. And we're able to make multiple connections, multiple active connections on every radio in a node. Now, that in and of itself is a major departure from 99% of the wireless networks in the world. Most wireless networks, things that you're probably more familiar with, like a cellular network or a Wi-Fi network, they let you have one active connection at a time. And if you've ever, it's really good, and other times it's not so good, it's because of signal degradation, interference, or obstruction to that single connection. If you have a network with multiple active connections and that network is dynamic and can continuously select the optimal connection, then you have a higher um, probability that your network is going to perform at top performance levels all the time. So imagine if your network was intelligent enough to self-optimize. That's what a Ragent network does.
And then from now that we kind of have that basic understanding, because with Ragent in particular, from what I understand, it's connecting those different nodes like you talked about, and it's doing it in some of the more extreme environments, so construction sites, underground, mining operations, so things like that. So how do you even begin? I guess what does the equipment look like in order to go to the middle of nowhere, almost, let's say a mine, for example, and establish an internet connection?
So you're absolutely right. People come to Ragent when they have their most difficult and challenging communication problems. Um, I'm trying to think just briefly where to start. I know this show's mostly about logistics and warehousing, so maybe let's use a warehouse as an example. If you have a traditional, LTE or Wi-Fi network where you have one active connection, you're going to have a piece of infrastructure mounted either on the ceiling or on a wall somewhere, and then you're going to have a client radio. Let's say you're a forklift operator, you're driving around the warehouse. There'll be a client radio on your machine, right? As you drive around a rack or a large shelf, you're now getting a obstruction between you and the device you're trying to connect with, because wireless networks universally are line of sight communication devices. So when you only have a single active connection and you're dealing in an environment with lots of obstructions, whether it's an underground mining tunnel, whether it's an oil refinery with all kinds of metal piping and equipment, or whether it's a warehouse full of racking, you have obstructions, right? So in Ragent's case, we still put up network infrastructure. We still hang those nodes from the ceiling or mount them to the walls. We also put nodes on machines, on robots, on AGVs, They can even be man worn. And each radio in each breadcrumb makes many active connections both to fixed or infrastructure nodes, but also other mobile nodes. So as you move around a rack, for example, you're continuously looking for new connections, and the breadcrumb is continuously evaluating the quality of every one of those connections and can change the path that data is taking to get from your machine back to the database that's recording all the workflow that you're trying to track. So by having this dynamic multi-connection network, you're able to stay connected with extremely low latency, and have plenty of bandwidth to do your job efficiently. Whereas if you're using other networks that only have a single connection and are not as dynamic, they struggle to maintain that continuous connectivity.
And so is that because I've always just in my home in particular, so we have fiber internet and it worked great for a while, and then all of a sudden it stopped working as great, and then the ISP, internet service provider, tells me, oh, you just need the extra connection points, and I'm thinking, well, isn't that convenient? Because then I have to pay you an extra fee for all of these different devices to connect. But now it kind of sounds like maybe they're not ripping me off, and maybe they're just trying to help me. Is that a safe?
No, I would say they're being honest with you. So I think what you're describing are specific Wi-Fi issues. So Wi-Fi has a couple things that are unique. Within the Wi-Fi protocol, there's a rule that basically says a Wi-Fi access point has to divide its bandwidth equally among all of the clients that are connected to it. So if when you first got it, the only devices that were connected were maybe your smartphone and your computer, you've got two devices, they each get 50% of the bandwidth, everything's fine, but then maybe you add a Ring doorbell, you add some Amazon Alexa devices, you add a smart TV, and these things are connected all the time, and they're now taking portions of the bandwidth out of that access point, whether they're using the bandwidth or not. What you have available for your smartphone and your computer has now decreased.
And so is that a similar situation of what's going on in, say, warehouses, for example, where it's so many conflicts? I imagine being surrounded by steel or something, depending on what the building is constructed with, that affects the wireless signals going on throughout the building as well.
Yeah, so you have issues with client density, which is what I was just describing. Wi-Fi also has a unique issue where the farther you get away from an access point. Sorry, my watch is deciding it wants to talk to me. Siri's not being very helpful at the moment. The farther you get away from an access point, the weaker your signal is. We've all experienced when we get down to 1 bar of coverage where the data rate is slower. But what most people don't realize is even if just one client on an access point has 1 bar of coverage, they effectively slow down every other client on that access point. So, for example, if you decided to put a satellite Ring doorbell alarm in a socket in a bedroom in the back corner of your house, and now that's the furthest device away from your access point, that weakest client connection now retards every other client connection on the same access point. So applying that to a warehouse, if you have a robot, for example, or an AGV that's moving packages around, and it drives down an aisle and it's getting further and further from an access point, it's not only affecting its own throughput, but it's retarding the throughput of every other device connected to the same access point. In a Rajant network, where we're using breadcrumb to breadcrumb, we're using a different protocol. We're not relying on the Wi-Fi protocol. We're using a proprietary protocol that's designed around supporting mobility. So because we have many connections, that same scenario, you're driving down the aisle, maybe you are getting farther away from an infrastructure node that's mounted to a wall, but you're getting closer to another AGV that's in the aisle. So now it decides, I'm not going to talk back to the infrastructure behind me. I'm going to talk to the robot ahead of me, and then it will relay my information to the next robot, and then maybe to a piece of infrastructure to get back on a wired network.
So the robots are almost in a warehouse environment, like the example you're using. They're almost like the wireless hub and the signal, if I'm understanding you correctly.
Exactly.
It's so. Oh, go ahead.
So I was just going to say, like in a Wi-Fi network, your access point is more intelligent and sophisticated than the Wi-Fi client. The same in an LTE network. The cell site has far more intelligence than the cell phone. In a Rajant network, every breadcrumb has the same intelligence. Okay, so every one of these individual dynamic units is able to make its own routing decisions, monitor its own connections, and they all work autonomously and independently, choosing the best routes to self-optimize and dynamically ensure that the network's operating at its highest available performance all the time.
And so, sticking with the warehouse example, so are you is Rajant, manufacturing these robots? I think there's another phrase that you guys use is cobots too. Are you guys manufacturing them, or is this maybe like an integration or a component that's added to the robots and the cobots?
So we do not manufacture robots. So we are just a communications company. We are application agnostic. We work in all kinds of industrial industries, and we work with all sorts of manufacturers as well as end users to help them have better communications. You can think of Rajant as the tech that makes tech work better.
And so, is it like an actual device, or is it just an integration software wise, maybe API or something like that? Not API, but
Well, we do have an API, but it is a device. So it's a box with discrete radios inside. It has a computer inside, and that's what makes up a breadcrumb. We also have some other secret sauce components. Nobody else quite builds a device like a Rajant breadcrumb, and it enables that mission critical communications that you can rely on in the harshest of environments, the harshest circumstances. We have breadcrumbs deployed north of the Arctic Circle, where they spend 9 months of the year ensconced in ice. We have them deployed in the deserts of Northwest Australia, where they have average daily temperatures above 150 degrees Fahrenheit. These are very rugged, robust pieces of equipment, and they're purpose-built to help people working in the harshest environments, in the harshest of circumstances. And even the U.S. military uses them to help protect the lives of American servicemen and women.
And you mentioned that mission critical connectivity, because I imagine that there's a large safety component to that as well. Being in these harsh environments, if something goes wrong, at least you have sort of that connection to the outside world that you can say, hey, we need help, or hey, this issue is going on. Is that a safe assumption?
Absolutely. I mean, think of the recent train derailment in Palestine, Ohio. That is a big safety component. Had they been able to remotely stop that train before it derailed, we would have had the disaster that we had. Pretty much every industry has safety elements and components that they're worried about. Even warehouse logistics if you have an automated warehouse where you've got robots and AGVs moving cargo around, and you also have people interacting with them, well, you have a potential safety hazard, and you better have a reliable way for the people to communicate with the robots to say, hey, stop, you're either possibly running over a person, or going in an area that we don't want you to right now, or there's all sorts of unforeseen circumstances, because at this point in time robots are not particularly self-aware. We put sensors on them to try and detect things. We put software safety measures to try to help them think and react. If they see something that's unexpected, that they stop. But there's so many circumstances that happen that are unexpected that they don't have code for, that sometimes you need a person to be able to hit a button and make all the automation stop, just to get everything back under control and back in a predictive environment where the robots can safely operate.
Is that what they mean by the phrase cobot? It's almost like a co-worker instead of a, I don't know, like a cobot is, helping you work throughout a warehouse?
I'll be honest, I haven't heard the term cobot. I'm not quite sure what they're referencing when they say cobot.
That's what I would assume, is that it's not like a co-worker, it's like a cobot, where it's helping you do your job faster, is what I think they meant by that phrase. Okay,
Okay.
so we talked a little bit about warehousing, especially with how Ragent is powering, that sort of the communication aspect of logistics. But what about like the port infrastructure? I saw this cool video that had almost what looks like drones that are flying around the port and connecting to the trucks and connecting to containers on the ship. Tell us a little bit about how that connectivity works, and how that's being that level of communication is being optimized.
So let me first tell you what the communication challenge is in a
Please.
port. Um, and there's lots of different kinds of ports, right? There's container ports, there's vehicle ports, there's bulk material ports, but let's just talk about a container port for a minute. In a container port, every day you're unloading containers off of cargo ships. You're stacking them up at the terminal, and then at a different point in time, trucks are arriving at the terminal to pick up the containers, right? All of these containers are serialized. They all have a number that's associated with them. In a perfect world, that number gets recorded every time that container gets moved. But as we know, the world is not a perfect place. And if you have a hiccup in your communications system, when you set the container in a particular stack at a certain height, if you don't get that recorded in your database, you effectively lose the container inside your terminal. It's not lost, but you can't lay your hands on it, and your customer's certainly very frustrated because you can't tell them when it's going to leave the port and start its journey across the country to get to your electronics store so you can sell all your new flat screen TVs. So because you have this dynamic landscape where the piles of containers are rising and then falling and rising and falling every day, it can be very difficult to plan communications. So we build a network in a port much the same way as we would in a warehouse, where we typically are mounting fixed nodes that we call infrastructure on light poles around the port. And then we also put breadcrumbs on the equipment and the machinery that's operating in the port, on the cranes, on the strad carriers, on the container lifts that are kind of like big forklifts, on light vehicles where you have people jumping in and out of a truck to do a quick inspection or verify something, so that you have this dynamic web of communications over the port that allows the signal to come into the spaces between the containers from multiple different directions to provide more reliable, robust communications. I was talking to the director of a large port in Canada on the western seaboard a couple of months ago, where we deployed a Ragent network a couple of years ago, and he was telling me it was transformative for their operations. They don't have the issue of lost containers. Before they had a Radiant network, periodically, maybe once a month, they would have to pause their operations, get all of the longshoremen that worked in the port to line up maybe 6 feet apart and walk through the terminal with a list of lost containers, looking for these serial numbers, trying to locate them so that they could then record in the database where they were and then make sure they got taken out of the port, put on a truck, and they could go on their way. Because if you don't know where your container is, it's as if, thieves had taken it as far as the customer is concerned. Now, the port operators, I feel bad for them, right? They don't want to lose a container. They don't want to misplace somebody's cargo. They want the container to come in and to go out as quickly and smoothly as possible. But if you don't have mission critical communications, you're going to have an interruption to your process. Imagine, for example, you order something on Amazon. Amazon ruined the customer service experience for every other company in the world, because now we as consumers expect Amazon response information and tracking on everything we buy, whether it's an automobile, a TV, a refrigerator, whatever. We all expect it to be like, the snack we ordered from Amazon. But the Amazon process only works if you have really good communications and tracking at every step of the process. If you fail to record the receipt or the departure, then suddenly when you look up the status of your package, it's like, well, it was here last Tuesday and we're not sure what happened to it. And it does happen, even with Amazon. And I'm not bad-mouthing Amazon. They do an amazing job. But we've all probably had the experience where we've ordered something and it gets to a certain point and then we're just not sure what happened. And then maybe a week later, it just shows up at our door and we're like, well, I guess it finally found its way to me. I'm happy. But it's very discomforting when we don't know where our package is or when it's going to arrive. And it's the same for commercial operations that are shipping things around the globe. If they can't track it and don't know when it's going to arrive, it's hard to plan for.
Absolutely, because I mean, even I don't know, a $20 pair of pants or something is a little bit different than like $20,000 or $200,000 worth of merchandise in a container. You absolutely want to know where that is at all times. And so, as you were talking and watching the research videos for this interview, with looking at a lot of the different port communications and things like that, I can't help but think of like use cases for like autonomous vehicles while at the port, moving containers to different locations and things like that. Is that a practical use case for Radiant's communications as well?
Absolutely. We do lots of work with autonomous vehicles in many different industries because, as I was mentioning before, robots, autonomous vehicles, they're not yet developed to the point where they're self-aware. We can't put them in an environment and give them a job description and expect them to do a job. Instead, what we're doing is we're giving these machines tasks. We're giving them very simple, specific instructions, and they're a task, and they go and complete the task, and then we give them the next task. Well, to give those tasks to them, we have to be able to communicate with them. If for some reason they become disconnected from the network and lose connectivity, well, now we can't give them the next task. They also can't report that they completed the task or report where they set the container down. And so the operation and the whole promise of autonomy breaks down and has issues. And that typically requires human intervention at some point. When you have a port terminal that's fully autonomous and suddenly one of the machines loses connectivity, they have to shut down every autonomous machine. They have to then send a person into the autonomous zone, they call it, to get on that machine, manually drive it, reset whatever to get the communications restored, and then they put it back in standby mode, and then they slowly put all the other machines back in standby mode. And it can honestly take 2 to 4 hours for the operators to get all of the autonomous equipment back online and working again. So don't imagine losing connectivity is a small thing. It's a huge thing. It's the lifeblood of an autonomous operation.
And so with all of these different, connection points and how that gets initially established, I imagine there's a large cybersecurity angle to a lot of these different connection points. Can you speak a little bit about, I guess what kind of security parameters are established? Is it on the company to provide that? Is it, you guys are providing that? How do the cybersecurity parts work between wireless connections with all of these different connection ports?
So there's multiple layers to cybersecurity. You have typically wireless networks are connected to wired networks. Wired networks have users. They typically have user accounts. Different users have different rights. Sometimes there's, IT security administrators. There's physical firewalls. You still need the firewalls, the user accounts. Since we're a wireless network provider, what we provide is very good encryption of the data. So while it's traveling through the air, it can't be intercepted, captured, and stolen, so to speak. It's one of the reasons the U.S. military has selected us for some very sensitive programs, because in mission critical operations where people's lives are at stake, they need to make sure that data gets across the areas that need to be communicated without the chance that somebody can interrupt or intercept and decrypt the information that's being transmitted.
And so, with the outside of the cybersecurity angle, we've talked a lot about from a warehousing point of view, from a port point of view. But I'm curious if you have any, outside of logistics, if you have any favorite use cases where Rajant has been applied. Like mining operations, military. You mentioned earlier, the Arctic Circle. Do you have any use cases for Rajant that you particularly think are the most fascinating?
Oh, we've done a lot of really cool, events. A month or two before COVID started, I was involved with one of our resellers at a freestyle skiing event in Aspen called the Aspen Open, where they had an issue where they had what they called a split judging panel. So the Aspen Open, there are multiple events that skiers participate in on a single ski run. And so they have one set of judges that judge one of the events, and then they have another set of judges that judge another event. And it's important for these judges to be able to collaborate in order to come up with the best overall score. And the purpose of that is giving all of the competitors the best credit for everything they did on the run and making the competition more competitive. So we set up a network basically in a day on a ski run, and we're able to capture video all the way down the run. And the judges were able to sit in a nice, comfortable conference room and have, coffee and donuts, and their hands weren't frozen as they were taking notes on the competitors. They were able to actually see instant replay. That was a fun one. We did another one last year at a mine in the central eastern United States that had what they call a subsidence. This was effectively a failure of the structure supporting this underground mine, and the whole mountain under which it was dug collapsed. And the good news is no one was
Wow.
hurt. So there were no fatalities and no injuries, but MSHA, the Mining Safety and Health Administration, who oversees safety in mines across the United States, told the operator they could not let anyone go back into the mine unless they were able to figure out a way to do an unmanned survey of the mine. And so we equipped several autonomous robots with our breadcrumb nodes and sent a convoy of them into this underground mine where there's no lights, there's no power, there's obstructions because the roof is fallen in, and they were able to spread out. And we got these robots. The lead robot got 2 kilometers deep into this mine where the subsidence was. They were able to send 4K video back out to the surface, along with, they also had a LiDAR sensor um, where it takes a point cloud. And I don't know if you've ever seen any of the National Geographics where they fly over the jungle in
That
Central
was going to be
America
my
and
next
strip
question.
off the lift station. Same
Cool.
technology, but it can work in the dark very effectively. So they took a point cloud, which is a massive amount of data, and we were streaming about 80 megabits per second uh, from robot to robot to robot out of the mine to the surface where they captured it, recompiled the point cloud, and within less than an hour, they were able to virtually, with in front of the MSHA inspector, let him see as if he were walking through the mine what the conditions were. And he immediately said, wow, this is amazing. And we can start formulating a plan to let people back in. Now, I had the opportunity to visit this mine during this inspection and talk with the MSHA inspector. And it was really interesting because he said to me, when we told the mine they could go back in after they did an unmanned exploration, we were just throwing them a bone. We honestly didn't believe there was technology that would enable them to do this, but we didn't have the heart to tell them they were never going to be able to go back in this mine. And he said, we're blown away at what your technology accomplished. And from now on, if there's ever a cave-in or a subsidence in an underground mine in the US, you can guarantee we will stipulate that they need to get a hold of Rajant, and Rajant can help them set up an unmanned inspection of their underground mine so that we don't have to send people into unsafe areas before we verified that the conditions are safe enough for people to go back in.
And I imagine that this would have use cases in several different industries. I mean, archaeology comes to mind as far as, exploring a lot of Central and in South America using LiDAR technology, things like that. But to explore these buildings and these structures that haven't been explored in hundreds, sometimes thousands of years, is that a safe assumption, or is maybe that in the works?
Absolutely. That's absolutely a great example. We've also used these with firemen who are in a hazardous material situation. Let's say there's a building at a chemical plant. They have to go into a metal building and there's a fire. They can take breadcrumbs with them along, they're wearing their hazmat suits, and they can build a network because we can transmit voice, video,
Oh,
and
wow.
data over the same
Hmm.
network. Um, so this is a network just like you have in your home or your office. It's based on what's called IP, which stands for Internet Protocol. So it's the exact same network everybody's used to working with in their office. Basically, if it has an Ethernet plug, you can connect devices into it and transport the data over our network. So it's very simple to use. And it has countless applications in dangerous environments.
Any plans to get this technology into conference and events? Because the Wi-Fi is always terrible at conferences.
Well, to be honest, we use it a lot for ourselves at conferences and events. Um, we quite often have sample networks set up around our booth, and
Smart.
people are often amazed because they know how horrible communications are at trade shows. Um, in 2 weeks, we'll be at ProMat in Chicago, and I'm sure we'll have a demo network set up there. If anybody would like to stop by our booth and check it out, we'd love to show it to them and tell them about
Yeah, what
Ragent.
what a pitch to be just tell people don't use the crappy conference Wi-Fi, which is a racket anyways. Come over and use Ragent instead. So what does
No.
the with I don't want to say it sounds complicated because as you're explaining it I'm like, okay, that makes a lot of sense, but I imagine for a lot of folks who may be used to, I think of like my dad, who is, the typical blue collar worker. If I tried to explain what Ragent is to him, he would probably be scratching his head 30 seconds into the conversation and his eyes would start glazing over. So how do you, like the sales process, the onboarding process, what does that look like for you in your position?
So, well, maybe I'll first tell you how I would explain our
Please,
system to
yeah.
somebody like your dad, and then we can talk about the sales onboarding process. So, most people have a smartphone today, and I would imagine your dad has a smartphone too. And most people have used their smartphone to connect to a wireless network, um, mainly a Wi-Fi network. And I usually ask them, so walk me through the steps that you do on your smartphone to connect to the Wi-Fi. And they'll usually say, well, I go into settings and I click Wi-Fi, I see the list and I pick one. And I said, okay, if you want to imagine what it's like to have a Ragent network, imagine instead of just picking one access point to connect to, what if you could select pick all? What if you could connect to every single access point at the same time and your phone was smart enough at any moment to decide which of those access points had the best, fastest, most bandwidth and sent the request that way? And maybe it brings the response back a different way because it was even faster. That's how a Ragent network
Hmm.
functions. It has all these connections and it's dynamically picking the best one. So most people go, oh, wow, yeah, that would be cool. So that's kind of the basic how I explain how Ragent works differently than other networks they might be familiar with. As far as the sales process, Ragent has reseller partners around the world. We don't sell through Best Buy or Fry's or your favorite electronics store. We're not a retail wireless network. Because of the technology that's inside a breadcrumb, it's going to cost more than your basic home Wi-Fi that you'd go to the electronics store and buy, or that you'd get from your internet provider. So we sell through professional value-added resellers or integrators who work in different industries. Most often, they introduce us to their customers that are having communications problems, and either they explain the technology and demonstrate it themselves, or occasionally they'll invite someone like myself to come with them, and we do joint presentations and joint demonstrations to show them how the technology would apply to their environment. Um, and it's really rewarding to see the amazement and the excitement on their faces when we're able to do things they've never seen done before with other competing wireless solutions. And they're just shocked and amazed, and they're like, oh my gosh. And then they buy the equipment and they put it in, and you go back and see them, and they are just such, I hate to use the term fanboy, but I mean, they're giddy about, oh my heck, you just transformed our whole operation. The IT department used to be the laughing stock of the company, and now nobody does anything without calling in the IT department and consulting with us first, because now instead of our solutions not working, They work so well, and everybody uses them. Everybody relies on them, and it makes everything in the operations smooth. And the other funny thing is how many times we see people get promoted after they've put in a Ragent network. I've seen it countless time after time after time. They buy a Ragent network, and 6, 9 months later, they've got a new job with a bigger title and I'm sure a bigger paycheck because they solved some of the most difficult problems that the companies were having, and their stature and their job changes.
Yeah, I mean, it sounds like a good pitch out there for folks who are experiencing connectivity issues, and you also want a raise or you want a bump in your job responsibilities. It sounds like that is the perfect solution for them is to contact Ragent and get some connectivity issues fixed. And so, with a lot of you've talked about a lot of the challenging locations that you've installed the technology. Are there any challenging locations that you haven't integrated with yet, but hope to in the future?
Oh wow, that's we've done some limited work with motorsports. I think there's a huge opportunity in motorsports. If you like, I know along the East Coast, stock car racing is a huge thing. People might think, oh, well, we have streaming video off cars now. On a very, very limited basis, there's streaming video off cars. You basically have a guy in a helicopter with a telescopic antenna hanging out the door pointing at one
Oh, wow.
car. And he literally has to aim his antenna at that car and follow it around the track to pull video off that car. You never see a screen in a motorsports race with 20 different cameras all streaming at the same time. Never happened. You see like the overview of the track from the fixed camera, and then you might see one little window with an in-car camera. And that's because the guy in the helicopter's tracking that car around the racetrack. We've done lots of tests with various motorsports companies. There's a professional race car team that deploys Ragent at the track to help pull machine information off their car, but we have not yet signed a deal with any of the, like the Indy League or the Formula One League to have Ragent at every track for every race so that they could get streaming video off every car. I believe that's coming. There is a project going on with one of the sponsoring entities for a motorsports league in Australia that's doing proof of concepts. And I think that's kind of to come. If you go to YouTube, you can search Ragent race car, and you'll find a few different tests that we've done. And Ragent's really the only solution that's going to work for that kind of an environment. So I think that's something we'll see more of in the future. But it's a technology that really could be applied to any number of solutions and scenarios and environments and industries. And if people need better communications, I would say if like in a warehouse environment, if you have robots and you don't feel like you're getting the full value out of them, 9 times out of 10, the problem is not your robot. The problem is your network.
Well, wow, that's a really, I think, a fascinating place to end this conversation, because this has been filled with a lot of different gems, and I think you're out here solving problems that folks don't know that they have until they're actually in those conditions and in those environments to experience the frustration of not being able to connect to certain devices, just depending on where you're located or where your work seems to be located. So Todd, this has been a really great discussion. Where can folks follow you, follow Ragent, all the work that you guys got going on?
You can you can follow Rajant both on our website, www.rajant, it's RAJANT.com. We also post almost every day on LinkedIn. You can also find me, Todd Rigby, on LinkedIn. And, if you have a communications problem, come to our website, drop a note, or give us a call. We'd love to talk to you. We'd love to help you solve your problems. Um, I will tell you unequivocally, Ragent has a mountain of happy customers.
That's awesome. I mean, obviously, you're touching a bunch of different industries in really fascinating ways. So this has been a great conversation. So appreciate your time again, and I will link to all of those things that you talked about in the show notes just to make it easy for folks. But thank you again, Todd. That this was great.
Well, I appreciate you having me on your show. I enjoyed the conversation, and we should do it again sometime.
Absolutely. Hopefully, you'll be fixing conference Wi-Fi next because it's the bane of my existence.
That's another good opportunity for us, I think.